Hello everyone, welcome to this video. In this video we'll be looking at more results on the order of an element. So let's start with the first result here. Using the previous theorem, these results are based and derived from the previous theorem as special cases, right? So the first result here is that suppose we have some group G, right? For that group here, suppose this is the group G. From this group we take an element A from it, and then according to what is the order of this group, one is this thing, another thing is that we have a subgroup which is also generated by this element. So the order of this subgroup is exactly same as the order of this element A here. So this is the first result over here. So it tells us that for any group element A, right, the order of A is exactly equal to the order of the subgroup A, right? Now why this is so? Because you already saw in the previous video that what is this set? This set consists of all the elements of this kind E, A up to an minus 1. So what is the order of this subgroup A, which subgroup which is generated by A? So the order here is equal to n, right? And if the order here is n, and we also assume that the order of the element A is n, so you saw both the order, they are equal to n, and hence they are equal to each other. Next, let us move on to the second result. The second result tells us that if we have a to the power k is equal to e, then this implies that the order of a divides k, right? Remember, the order of the element a was equal to n in our previous case, right? So now we wanted to prove that if this order means a to the power n is equal to the identity element. Now if we also have a to the power k is equal to e, then they are saying this n would divide k, right? So this is the result here. So here the statement tells us if G is some group and A is some element of order n in G, then if a to the power k is equal to e, then this n divides k, right? Because we know the order of this element A, that is equal to n, right? This thing we already know. So a to the power n could be written as e, and n is the least positive integer of such kind, such that a to the power n is equal to e. Now in the statement they are also giving to you as a to the power k is equal to e, and you may write e as a to the power 0. So that means you have a to the power k as equal to a to the power 0, and you know n is the order of a. So that means according to the previous result, so this result here, now if we have this thing that a to the power I is equal to a to the power j, then n, where n is the order of this element A, right, then this thing would divide the power, the difference of the powers, that is I minus j. In our case we have a to the power k equal to a to the power 0, so that means the order which is n would divide their difference. So the order n would divide k minus 0, so all in all n would divide k, and this is what we wanted to prove here. So I hope you understood these results. Well, that is it for this video. Thank you for watching.